All right, our Age of the Seafloor Elaborate is pulling together some of those big ideas from the seafloor and then getting a little bit deeper into them as we get ready for our test coming up in a few days. So we want to know, first of all, thinking back, our continental drift hypothesis was the idea from Wegener that said, hey, all the continents were connected at one point, which was a great idea. But what was wrong about it, what he was missing, is how those continents were moving, right? He couldn't explain how the land moved. He knew that they did, but he couldn't explain the how everything moved. So where did we end up deciding to look to figure out how the continents moved, right? His evidence wasn't enough, so we needed a new spot. So we started investigating, of course, our seafloor. We started looking at both age and sediment thickness down on the seafloor to get an idea of something going on there that's pushing the continents apart rather than them drifting apart. So this is the info that we should already know about the seafloor. Again, this should be like a review. Okay, the map below shows us the ages of the seafloor around the world. So this is a map like we created on our desks, right? We saw this rainbow pattern going across the ocean, but here we're looking at really the entire seafloor. So we've got, North America, South America, Africa, Europe, Asia, Australia. Here's Antarctica down here. We're looking at this time all of our seafloor, and here's our age range. So this red is our newest or young oceanic crust, and the farther out we get in this blue and this purple range, this is our oldest oceanic crust. So when we look across the seafloor, we should be able to elaborate on some of those patterns. So you've got a question about what color is what age. What do I notice about the entire seafloor? Is it the same age? Yes or no? And some observations, to go with it. Like, where do I see certain ages? Which color maybe is the most as I go across ocean to ocean? What do I notice? Or maybe giving a location, right? Close to Australia, here's what I notice compared to close to Africa or something like that. And again, all this is happening because of that idea of sea floor spreading, right? We have our ocean floor underneath the water. And so what we've got in kind of that middle area, the center of the ocean, we have our convection happening right in the center, and our ridge push occurs, breaking its way into the earth, separating the plates and slowly pushing our continents apart, right? Our North America and our African continent are getting further and further apart because of this magma being driven up at our mid-ocean ridges, or the middle of the ocean. That's where we see our new ocean floor forming right at the middle of the earth. And again, this is happening because of that convection underneath the earth. Material comes up, ridge push separates underneath, driving my two plates apart, or my lithosphere apart, and because those continents are on the lithosphere, they are separating then as well. Number 5 is kind of a prediction question, a little bit new idea here. We see the red area at location X, a lot larger, a lot more red new rock than we do here at location Y. So we're just getting you to kind of predict or guess, what would be a reason, knowing what we know about underneath and what's happening in the first place. How is it possible maybe for one location to have more new rock than another? And if you need help with any of the calculations, check out the next video.